Let me extend a warm welcome to the participants of our current club event, in particular to Áron Vitályos, who accepted our request to deliver the keynote speech of this club event. Our club is about rule-based support of IT systems. On previous occasions, we have approached this from an authorization point of view. Áron was the CEO of CIB Leasing earlier, so we asked him as a business decision maker how he sees it. What is the benefit of decision automation in business processes? Where are its limits? And what experiences can he share with us? With this, I'd like to turn the proceedings over to Áron Vitályos.
Thank you for the honor of your request. As Zoltán pointed out, I will speak about decision automation and specific experiences. Before jumping into the topic, I'd like to start with the definition of what I understand by decision automation. Basically, it is the collection and arrangement of information into appropriate structures, then highlighting the decision that becomes necessary based on these, or its alternatives. Eventually, it is finding the optimal solution out of the alternatives, based on available data and sets of rules, all this with minimal human interference. This is decision automation based on my definition. In the first round, I'll try to find an answer to this. What are the criteria that induce decision automation? I think this is a very popular combination of words, not only nowadays, but also in the recent past. Basically, one of the most important objectives that makes companies think of decision automation is the efficiency increase. Efficiency may mean cost-cutting, even layoffs, obviously, or providing a higher throughput with existing capacities. I think cost saving is a very important criteria. Unfortunately, the emphasis is mostly on this nowadays. Market opportunities have shrunk significantly. As a result, the focus is less on revenue increase, and almost all companies try to decrease their cost base. Decision automation can be a proper tool for this, if prepared and used appropriately. I think the emphasis here is on preparing these automations appropriately. Another important factor is the quality increase, or ensuring constant quality. The more human interference we have in relation with a process or decision, the greater the deviation can be, both in theory and in practice. This means that individual decisions are not necessarily consistent with each other. Obviously, in case of an automated decision-making mechanism, this happens rarely. This way we have a process with much less deviation. If the number of items is high, this should be a particularly important criteria. Process monitoring and analysis. I think decision automation is a necessary but not sufficient tool for this. By that I mean that we can measure lead times related to individual decision processes, and it is easier to find bottlenecks compared to the situation without tools. The whole process is documented. This ensures that the decisions are documented better. The next important thing for decision makers is the information provision. In today's world, an incredible amount of information is flooding not only the top leaders, but middle management as well. One of the most difficult tasks is to structure and arrange this information appropriately in order to prepare or support decisions. A properly automated decision-making process can provide help in this regard. And last but not least, I'd like to highlight the split of responsibilities. In case of human decisions, the responsibility lies unambiguously with the individual who made the decision. With regards to an automated decision-making mechanism, I think the responsibility matter is changed. Obviously, the process definition, the decision mechanism required for decision-making, is usually put together by a committee or a team, not by a single person. I think we have to take into account this aspect as well. The next very important thing with regards to decision automation is, how well are the processes and the automation itself prepared? Maybe one of the most frequent problems is that there is not enough emphasis placed on the preparation of the process to be automated. Information is either not available or not fully available. The process to be automated is in a lot of cases unclear. Process maps are missing or not up to date. The process may have dead ends or infinite cycles that can be discovered only by thorough preparation. Based on my experiences, another frequently occurring problem is when we have a process that is too complex, badly structured, and it cannot be automated yet in the current form. I can give you examples either in politics or in relation to the operation of large organizations, financial institutes or telecommunication companies. The automation of these badly structured processes is more of a curse than a blessing. It is definitely required to properly standardize these processes first, and after that it's worth or it makes sense to automate decisions. With regards to the automation of decision-making processes, a very important aspect is that in many cases roles and responsibilities are not defined appropriately. This can be a problem, for example, in case of a loan process or an investment decision process. If the roles and responsibilities are not defined appropriately, then clearly the automation will not be able to determine either which levels should handle the decision or who should approve the given decision, or who may overrule it. I think this is a very frequently occurring error. Another problem that can occur, even in case of a good process, is the following: I may have a good, mature, and standard process, while the internal or external environment is continuously changing. Looking at the external environment, a change in the legislation, a new decree or the competitor's behavior may trigger impulses towards the given company that must induce serious and quick changes. These changes can cause difficulties in an automated process if the given process cannot be parameterized appropriately. You don't even need the change of the external environment for this. A significant organizational change can cause problems too. Another general problem is that in many cases people try to automate processes that effectively require frequent manual interference. You may call it overrule or something else. Unfortunately, in many cases it requires IT skills to bring these processes back to course and help them continue. And last but not least, I'd like to highlight the communication problems between IT process designers and business decision makers. I think one of the most serious problems is that IT experts or analysts do not have an inch-depth understanding of the business problem during process automation. They get a specification and try to translate it into IT language. If the understanding is not appropriate or not deep enough, then it often causes problems in automation that are extremely difficult or impossible to eliminate. So the interaction and understanding between IT and business areas has to be a very important criteria, and it has to be taken into account. I'd like to present two specific examples in the following part. One is a good example, and the other one is a bad example for automating a decision-making process. At my previous workplace, shortly after the year 2000, we decided to automate the mortgage lending process. Almost all previously mentioned criteria were true for this process. So the base business process itself was not mature enough before we started the process automation. It had lots of participants involved, it had lots of feedbacks, loops, and deficiency remedies during the process. The cooperation of at least 15 or 16 participants was necessary to complete the paper-based process, and the necessity of human intervention was very frequent. This was the process we tried to automate, and the end result was a system having more than 170 IT screens, and one process instance had almost 1,000 data elements. All this in an internal-external environment that changed a lot in those times. The consequence of the project was that for 20–30% of the cases it took 3 or 4 times less time than earlier to complete. Translated to numbers, this means that instead of a process of say 3 weeks we had a process of 5–6 days. The clients served using this process were very satisfied. However, for all the other transactions or clients, where the request was not so much standardized, that is we couldn't keep the process itself on the standard path, it caused extreme difficulties. For almost each individual transaction we had to involve a separate IT expert or system analyst in order to complete the process. As I mentioned, the most important concern was the frequently changing environment. We had to touch the base process itself plenty of times, and that did have IT consequences. I think, back then the workflow systems were just unfolding their wings. These interfaces were not so easy to parameterize as nowadays. Obviously, in an environment difficult to parameterize, almost all changes caused code modification. This made our work very difficult. The bank used this system for 1.5 years, maybe 2 years, then they stopped using it and reverted to the paper-based processes. The next example I'd like to present is a process automation done a few years later, practically based on these learnings. The bank introduced this process for lending without collateral. In practice, these products were significantly simpler than mortgage lending, personal loans, overdraft facilities, credit cards, trade loans, etc. Obviously, these had much less uniqueness, much less participants, and the base process itself was much more mature. Besides, at that time the workflow systems and decision support systems were already much more mature from the parameterization point of view. The elapsed time of the project itself was 3 times less compared to the first attempt, and the success was in this case absolutely 100%. The bank was able to achieve significant cost savings using this development, the same headcount was able to deliver a significantly higher throughput, and the processing time of such a loan decreased from the earlier 1.5 hours to 15-20 minutes. Not to mention the fact that the maintenance and parameterization of the system was on a much higher level compared to the earlier attempt. The financial institute where we implemented this system continues to use it, so I think there are significant differences between the two implementations, not just because the product group was obviously simpler, but the company was able to utilize the previous experiences when creating this system. As a summary, what experiences can we draw in relation to decision automation? I think it is definitely important that the company or economic entity should have a long-term vision about actions before they start the automation of such a system. It's not worth making decisions with such implications for a cycle of 1 year. It is important that the system should be aligned with the vision of the given company. Another very important thing is that the process to be automated should be appropriately standardized, so a business process re-engineering or a lean exercise should be definitely necessary in relation to process automation. It is a frequent mistake that some companies and decision makers expect the process automation to deliver a solution, but the process has to be cleaned up before automation. I think in our case another important learning was that it's not worth or not allowed to focus on 100% of the cases. The Pareto principle is valid in almost all business environments, so I think, having a solution for 80% of the cases is more optimal from all aspects, cost, development time, etc. It is necessary to have overruling and handling of unique cases. I have pointed out that the common understanding of business requirements is very important. It is not enough that business users know what they want. It is very important to ensure that IT, the system analysts, understands the requirement the same way as the business defined it. If this understanding is there, developments go much more smoothly, and the provided solution resembles much more the business user's ideas expressed at the beginning of the process. I think it cannot be avoided, and the given organization or user must be prepared for the fact that there will be necessary changes. There is no system in the world, or there are very rare exceptions, that doesn't require maintenance and modifications. It is definitely required to provide experts with appropriate skills in order to quickly implement changes. This is by and large what I wanted to sketch, and I hope you have questions regarding what I said.
Thank you very much. The way I structured what I wanted to add covers in many cases almost 100% of what you said, Áron. Nevertheless, I think there are some differences in nuances, and I like to discuss those. The biggest problem I see is the following. Are companies aware at all of what they can expect from automation? It is relatively easy to talk about problems rather than about their causes. We started with process automation after the year 2000 because it seemed to be a trendy thing. Later, when we have seen that this is a very expensive game, then we have understood that we should have raised this question of maturity. Today the most important question is how costs can be decreased. This is a quite sad thing, because I will list some more aspects, but eventually we always arrive to this single aspect. And I state the following. If this aspect is not connected to other quality objectives, such as providing a better, faster, more reliable, more customer-friendly service, If the one single objective is to lay off, let's say, 30% of the people working in this process, then these people will not cooperate. Enforcing the company policy could also be an important driving force. If the given organization were aware of the cost of enforcing the policy and the cost of non-compliance, it would be easier to argue. Knowing the reasons for hidden costs definitely signals a certain maturity. For example, if all loans are approved individually, maybe in a few years it will turn out that there is some problem with the portfolio. Another objective that can also be a motivation is the one Áron mentioned also, when the company plans to grow with the same set of resources. If the people working in the process don't cooperate, then it is basically questionable whether we can understand at all the otherwise undocumented process. Without this, the mapping or using Lean or Six Sigma or some kind of restructuring of the process cannot be performed. So, if the driving forces mentioned on the previous page are not there, then the decision automation plan is probably sentenced to death. Of course, they have to buy the necessary tools and acquire the necessary knowledge for the tools. It's quite trivial, I think. Well, sometimes it isn't. Many tool vendor companies on the market say that their tools, technologies, and methodologies are easy to use. That when the given company eventually purchases the tools, they expect those to start functioning themselves. In fact, the money spending is just about to start. This should be clear for them, but it isn't. It should be also very clear what they expect as a result of the automation, specifically better cycle times, representation of the company's interests on a significantly higher level, making the process auditable, establishing the accountability of decisions, cost saving, of course, etc. All this should have a certain associated value before we start discussing whether it's worth doing and how. After all, continuous improvement and optimization of a basically well-functioning process can be performed using the, for instance, Lean methodology. If in reality there is no process and the individual departments and colleagues cooperate based on habits, partly ad hoc, then it's not possible to discover the process loops and dead ends in advance. I used to say, let's try to start with a reasonable version of the as-is process to learn it. Automation is not yet a characteristic of this start. Let's introduce the reasonable series of tasks as a process without any automation at first. This way it is possible to document the process electronically and we can track how it actually operates. Otherwise it's difficult to do this because most of the processes are crossing the company horizontally, usually don't have one single owner who could tell exactly what happens in which process step, what is the added value there, what is the risk, what is the expected service level, etc. Simply nobody knows these things, but everybody has an opinion. During the first iteration of process implementation, it is still easy to attach documents created in the process steps. This ensures a real business value, and this can help to justify this way. The real value of this iteration is that it can be measured where time is spent. When we have measurements, then we can start with Lean, because I have seen that in places where they didn't know the process exactly, although they thought they did and wanted to Lean the process at first. They started visioning and they started shoreless disputes. Often we had to fight with the more speculative problems. At the same time, Maturity in my interpretation also means that the process to be automated cannot be totally wrong. The issue with real processes is namely that they are effectively full with exceptions. And this leads us already to the 80-20 Pareto principle. I think a good approach is if we try to automate the most frequently used and most risky decisions of a process to a reasonable high level for each. Which one to take as a first, second, etc. to be automated can be decided with a precise measurement and analysis of the already running process. This means we will have at the end of the day a lot of decisions not automated at all. And even the decisions with automation will have a gray zone where human decisions should take place. Maybe I can highlight this a little bit better with the following thought. My statement is, a very big part of real process instances, much more than 80%, I would say, is almost standard. That means it requires human intervention in case of only a very small number of decisions. Unfortunately, the few number of these decisions varies by process instances. However, number of processes that can be run fully automated is much less than 20% and can be found only among the very, very simple processes. If we don't solve the possibility of human interaction at each decision point, then a very big part of process instances stays out of the automatism, so our whole effort is in vain. Áron spoke about this. If a proper automation tool is used for decision evaluation, for example a business rule engine like T-Logic's TCPS, then a fine-tuning can take place now, without the involvement of developers and process designers. Maybe at the first a particular decision is automatic only in 20% of the process instances, but as we improve our ability to analyze why process instances require human decisions, we will be able to learn based on actual cases what information the decision maker needs for decision, and if it's justified and information for decision is available in the process, then the automation can be extended without programmer's effort. It's very important. The process improvement itself is a long process with continuous learning, and it is not possible to build effective processes if the management is not dedicated to this topic on a daily basis. If a process affects several departments and there is no involvement of decision makers of highest level, then the prevailing criteria will be always those supported by stronger people.
I agree. As you pointed out, in many cases one of the objectives of process automation is decrease in headcount or incompetency. Obviously, the participants who are the most experienced with regards to the given process may perceive these changes as a decrease in their circle of influence. If there is no appropriate leadership commitment in such cases, then the affected people will not be partners in the success of process automation.
Yes, thank you for viewing it this way. I see this is as a very, very important matter. Key project participants have to be motivated. They have to feel that their work will be better and more efficient instead of feeling that they will lose their jobs. Maybe the real objective and the real saving would be the layoff, but in that case, you can't complete the project normally. You have to be prepared for handling conflicts anyway. It is very important to launch the project with clear objectives, accepted principles, and methodologies known to everybody. This cannot be the subject of continuous disputes during the project. There is fluctuation. Strong people join the project. Still, you have to complete at least one iteration of the project, draw the conclusions, and change only afterwards. The sponsor and stakeholders have to understand, and I'm very happy you mentioned it, that the change will be constant and it will have serious costs. It must be calculated whether it has a return or not. And I have made a note here for myself, what is very important if we speak about decision automation, namely the service-oriented architecture. It is obvious that automation can be performed only if information is available from the widest possible range. You have also mentioned the problem that this is not always a given. So if the information has to be collated from 6 to 8 systems or files and the appropriate services are not available, then the maturity is not appropriate. And it is very difficult to do the two things in parallel, namely construction of the process and building the service-oriented architecture at the same time. By the way, in the project you mentioned, it was done, unfortunately, this way. Usually there is a significant backlog in this regard. Not too many were able to implement a successful service-oriented architecture. But I have to say, if any one of the mentioned conditions is missing and there is no commitment to fill the gap and accept the costs, of course, then don't start. You will just cause one more frustrating experience to your company. Thank you, that's all what I wanted to say. Before entering the dispute, let's view Zoltán Tánczos Jr.'s presentation about the topic you also highlighted, communication between the business side and IT. You used several times the word parameterization. We would like to extend this a little bit because we think parameterization in the traditional sense is not enough in many cases. I will hand over now to my son.
I would like to continue with the topic, how can TCPS be used in decision automation? As a lead-in, I would like to give you my reflections. On the one hand, I think that a decision automation system can be implemented only iteratively. Also, the automation of decisions at a large scale can be done only iteratively. This is valid for process automations as well. We definitely need to be able to measure the results of the automation performed up to that point and what direction promises the highest possible return. A very important element of this continuous improvement has to be the tool used for decision automation. Áron has said that in the second project they did decision automation using a tool that was much easier to parameterize. I think it is clear that it has a very big importance what tool we choose for implementing decision automation. The other topic was already mentioned in the introduction, but I would like to highlight it because it is an important part of my speech as well. It is the IT business alignment. If you wish, the reconciled requirement specification, the understanding of the IT of the requirement specification, and the measurement whether the eventually completed IT work and the business requirements are corresponding. I think one of the key messages is when we automate a process, a lot of types of business decisions will be involved. I think when we talk about the parameterization and flexibility of the system, a very important aspect is the following. When we want to implement a change in the system, how is the parameterization done, in how many ways and in how many tools? So it's important for me to present how TCP is able to completely handle various characteristic decision types. As an outset, let me present a few definitions of thoughts about rules, rule engines, and various types of rule engines. I think a rule can be defined this way. It's a logical expression that consists of conditional statements and decisions that occur in the case the conditions are met. A rule engine is a tool, a software that is able to store these rules and provides administration and evaluation possibilities for them. That is, it can make decisions based on the available parameters and information. Rule engines can be divided into two large groups. This is our own definition, and it was brought into existence by the TCPS development. A rule engine is procedural if it builds up the rules using conditional statements, so-called if-then-else statements, just like a programming language. On the other hand, we distinguish declarative rule engines that describe and store the rules in a natural logical form, in their original form. Unlike procedural rule engines, they are able to function practically as an information store, a knowledge store. However, declarative rule engine has less capabilities than a procedural one, in the sense that it will not change the status of the system, that is, it will never execute the consequence of the decision. I have to tell you clearly that this less is in fact more, because it has countless advantages. If somebody is interested in the details, I will be happy to explain separately, but it doesn't fit into this presentation now. Since TCPS is a declarative rule engine, the objective in there is not to execute the consequences of decisions, but to provide the rules serving as a basis for decisions as completely as possible to the controlling logic. The controlling logic must invoke these decisions, then it must enforce their results. When is it worth using such declarative rules? I could say practically always, but probably you would like me to concretize this a bit more. On the one hand, if we want to use the same logical statement in multiple ways, because this is the essence of declarativity, the fact that we can view the same rules from multiple perspectives. I will bring practical examples for this later to explain this more. On the other hand, in cases when the often mentioned business IT communication is required to formulate the rule precisely, especially in cases when the rule is complex, it brings great value to present it to the business side rule makers and test it and verify it as a standalone unit. If it's a standalone unit, then it can obviously be installed and modified individually. I think that in case of such requirements, the TCPS rules have significant added value. An important argument for outsourcing to a rule can be the fact that the process or program requires this decision on multiple points, or multiple systems require it. It is a very significant and strong argument if the evaluation of the decision uses external information sources for making the decision. I think of cases like an authorization rule reaches out to the LDAP and queries the groups the user is a member of. I think there are certain types of rules that appear in each process affected by decision automation. The authorization rules are such a type. It's not a coincidence that the history of TCPS started initially with the support of authorization rules. Authorization rules appear in each process that requires some kind of human interaction. That is, practically all business processes have authorization rules. I try to collect on this slide the criteria that, based on our previous experiences, justify the usage of rules. Next to the individual criteria, I listed which ones are fulfilled and how for the given types of rule characteristics. Let me mention one more topic related to authorization handling. I think nowadays this is unsolved in many places, maybe exactly because solving the authorization handling with a declarative rule engine is not yet typical. My initial thought is that it would be important to keep the user task list free of spam. I call spam in the user task list a task which is not his or her concern in reality. It is assigned to somebody in his or her group or to a different department, and it is related to the given user only because she could execute it theoretically. The biggest problem with these tasks allocated for safety is that the user's task list will be full with tasks they don't really need to work on, and starting from here, difficult to identify those they should definitely work on. Often, the users find out only at the first escalation that among the many tasks that there was one that was specifically his or her duty. Typically, many more than needed users receive a task. The problem that causes this is that the task distribution is too tightly related to authorizations. I think everybody agrees with the statement that it only makes sense to allocate a task to somebody who is authorized to execute it. However, the opposite direction is not always true. Not all authorized people should receive the task. A good and easily understandable example is that in a given company the CEO may be authorized to everything, but this doesn't mean that all tasks should be allocated to the CEO. Typically, the tasks for which there are other people authorized shouldn't even be put to his or her burden. This is the interlocking I mentioned first between authorization rules and task distribution rules. If I'm interested in who at all comes into question to execute the task, then I definitely have to evaluate the authorization rule. This is another view of the authorization rule. Now, instead of asking whether somebody is authorized to make some type of decision, I will specify the type of decision, and I'm interested in who is allowed to execute. For example, I will specify what the loan amount to be approved is, and what type the customer is. Let's observe that this question can be answered based on the same logical statement, that is the same rule, but it requires a declarative rule engine. Following this, the task distribution is only a matter of priorities, namely another rule can describe who is the one who has to deal with this task in the first round, who is added in the second round if nobody was available from the first priority circle, continued up to the required number of priority levels. Another typical type of rules in decision automation. Definitely, in the course of decision automation, data and documents will show up as a basis for decision making. Especially in a process with a long cycle time, we cannot guarantee the elapsed time of the process, and some of these data and documents may become outdated. For example, a personal ID may expire, or a certificate of the registry clerk may lose its validity, and so on. In the third place, I mention a quite large group of rules, usually called product rules, and I would like to go into some detail here. These are the rules that determine when a given service or product can be provided. Related to this, let's step forward to the next slide, handling products using rules. Practically, I could say handling decisions related to the sellability of products using rules. Usually, in case of companies selling services as products, so in places where the product doesn't have a physical manifestation, we can say that, in essence, the product is the totality of conditions that have to be fulfilled during service provision. Another characteristic of the product is that these conditions are well documented and are the same for the whole organization. For example, if I enter a branch of a bank here in Budapest, or I do the same in another town in Hungary, and I requested the same banking product having a marketing name, then I should have to fulfill the same conditions, and in a good case I should receive the same service. This is what makes it effectively a product. This is another definition we chewed a lot. Actually, we tried to condense quite a lot of experiences into this definition. This is the basis for the remaining part of my presentation, so please take the effort necessary to essentially understand it. Actually, the key recognition is that, for example, banking customers differ in many ways, but the data model that describes them from the bank's point of view is the same in all cases. I could put it this way: customers themselves are different, but the information we have about them is the same in all cases. The same is true for products. Totally different services and products can be created in an organization, but these are all, in all cases, services built on the organizational data model, on the organizational data asset, that is, the totality of rules built on this data asset. Another very important question that we pressed several times so far: what does standard mean and what does exact mean? Even in the business requirement form, my answer is the conditions are exact if those who have to understand and enforce it are able to apply this set of conditions 100% exactly any number of times. Let's take an actual funny example from the past. Once we were coming back from a foreign country, and the passport of one of the passengers in the car has expired. The crew at the Hungarian border crossing didn't want to let him into the country. He took a small detour, and we went to a different border crossing, and he could enter there. It's obvious that either the set of rules was not exact, or it was not defined in an understandable way, but the enforcement was not consistent at all. There is a small figure related to it. When we want to teach the rules to those who have to work with them, everybody will understand them at a different pace, and unfortunately often a different way. There will be people capable of reproducing them well, there will be others who understand them a little more difficult, and there will be a few who find the loopholes and the possibility for misuse. The real goal would be clearly to have 100% enforcement. As a consequence, we should place controllers behind everybody. But actually, the objective of automation is partly to take this rule enforcement off the company's shoulders. The automated decision should remove the necessity that the users have to evaluate the rules the same way in their head. Don't misunderstand me. It doesn't mean that the users don't need to know and don't need to understand the rule in order to properly work with a system making automated decisions. If they don't understand why the system made a given decision, then that will be a constant source of problems. Another personal experience related to decision automation. When rules are implemented in a system which enforces them, it often shows that the users have misunderstandings or outdated knowledge of those rules. Sometimes this makes them think that the system is not working correctly. Doing rule validation sessions with key business users and rule makers during rule implementation is a perfect way to accommodate user knowledge and improve IT business alignment. The other typical problem is exactness, the inability of human languages to express exactness. Probably we don't need a better example than the multiple interpretations of legal text. Many people live well off of that. We have a little simpler actual example. The textually formulated rule generated a dispute not only between IT and business users, but also between different business users, whether the and or the or relation describes the actual business rule more appropriately. At the same time, this is an interesting example for the case that trying to make the rule exact reveals a hidden operational risk. In the given case, the organization was not aware that certain parts of the organization have interpreted the rule differently. A few thoughts about selecting the appropriate technology. I think it's not enough if the automation only supports yes-no decisions. In case of products, we always need the possibility to evaluate our rules from multiple aspects. Such a decision automation system will be really valuable if it can leave the user's hand in certain cases. What are the actual possibilities? What can she select in order to carry through the process on the path that complies with the rules? So it's not only about considering all existing possibilities, but the possibilities still allowed by the rules in a given situation. In case of business decisions, it can often be important that the system should provide a meaningful message even for a negative decision with regards to why the service cannot be sold. This also helps the sales. The goal is to send away the least possible number of clients just because they wanted to apply for a loan that is a few dollars more than what they could otherwise get. These different expectations have to evaluate the same set of rules but from differing aspects. Let's have a look how this is when implemented using a procedural rule engine. As I mentioned, we call it procedural rule engine if the rules are defined in a language that is basically built on XML statements. The rule engines on the market usually work this way. This expression, written in an upscale logical language, translated into a pseudo-procedural code, gives us a simple little program It's really very quick, very easy to write. Usually, these rule engines also provide a debugging possibility, so this program is really nice and quick to compose. But how can we extract more information from it? The base situation is that it checks the input information, and if it matches, then it returns that the transaction is authorized. Besides, if we would like to get information about what currencies can be used, then we must create another rule in a procedural rule engine that returns the currencies the customer can operate with in given cases. The same way, if we want to find out what is the maximum loan amount, that's again another rule. We have already implemented 3 rules, practically all of them from the same logical expression. The human mind could produce them easily and quickly. If we accept that in business application it is important to give an explanation if required to a negative decision, then we definitely have to add those as branches and return the appropriate messages. So we had to modify all our 3 rules. We take a deep breath. Okay, we are ready for a short while. I think that based on our previous experiences, all 3 of us have agreed that the one thing or sure thing in these systems is that there will be change requests. If there weren't change, it wouldn't be worth creating a flexible system. It occurred to me during your presentation, Áron, that the systems where frequent change requests are not characteristic are usually not problematic at all. They operate as they should for 1,000 years now. If they are implemented very well, everything is very good. If they are implemented a little worse, the organization got used to them anyhow. Serious problems occur always there, but changes are constant and the whole thing cannot settle. Well, let's execute a small modification on this. Up there we can see the logical rule. The change is that in case of the Hungarian foreign currency we decrease the minimum loan amount to 500. Unfortunately, this induced a serious change in our rule, in our procedural rule. We have to add a complete new branch, and this rule implementation still cannot answer the question whether, for example, a loan of 600 forints can be taken out regardless of the currency. But let's admit, this is an important question. The customer will choose from the currencies that make this possible. So, I hope we agree how important it is that the rule performs an evaluation even with an incomplete data content. I think we managed to point out that procedural implementation doesn't simplify the handling of changes or new requirements to a significant extent. Obviously, this is also true for the implementation in program code, because the most frequently used programming environments are all procedural programming environments. In these, different views and different evaluation possibilities of rules have to be implemented definitely separately. Let's have a look at another widespread solution. It is common knowledge that possible value sets of parameters should not be burned into the program, but stored in a relational database. What's the issue with this? On the one hand, it's obvious that we practically cannot avoid redundant storage. On the other hand, the operators related to individual parameters, that is, the relational operators, have to be similarly burned into the code. If the rule returns no response, that is, a select statement doesn't return any results, then we have no info why there are no results. Overall, I think this is a very bad idea. Even a procedural rule engine is a much better idea than this. Since we are in a TCPS Club, it's understandable that now we have arrived to the proper solution. Okay, jokes aside, we can really state that the declarative rule engine is definitely the ideal choice for rules that can be described with logical expressions. In this case, we implement the logical connections once, and then the rule engine is able to answer all types of questions that are meaningful for that rule. These are exact rules that will determine the course of the business in a given case. It is very important to apply a methodology that helps the business understand the actual rule implementation, That it makes possible the precise mutual understanding and the immediate verification. This ensures the IT business alignment. Based on our experiences, we state that this can be really achieved. Most rule vendors state in their marketing that business users can create the rules. In our opinion, this is true only for the very simple rules. We have seen that it's not necessarily true for the previously presented very simplified landing rules. We don't even claim this. We state that business users can understand the rules to the lowest detail level, they can validate them, they can participate in creation and testing, and usually they can actually perform on their own some modifications on a daily basis. I think it's not entirely true that business users create the rules on their own, because it makes sense to create a new rule only if some application invokes it or some application uses the decision automated by the rule. This definitely requires the cooperation between IT and business. So, the business cannot create rules on its own, and it wouldn't make sense either. The most important objective of the methodology is to be able to present the rule created based on requirements formulated in spoken language very quickly to the business client. They should be able to validate it and state, yes, this is what I meant. Misunderstandings originating from the verbal formulation are cleared at this point, and a very effervescent and fruitful discussion can start between IT and business users. The consequence is that the rules are working free of errors when transferred to the live environment. Another very important part of the methodology is the unit testing of the rules. This is also performed with the involvement of the business users. The unit here is a business rule. The test cases of the business rule must be business cases. One of the problems of IT is that they don't know the real business cases. They have to cooperate with the business users so that completed rule be tested for real business cases. This reveals the possible inaccuracies or contradictions.
Let me here emphasize the time perspective separately. So from the time business explains the rule until the testing can be performed, it will take a few days only. The business user don't have to wait for the completion of the whole process invoking the rule. Without this approach, too much time is spent until a program is more or less suitable for testing after a long coding and testing period. In this case, it is difficult to separate the errors resulting from the integration testing itself and the ones caused by incorrectly working rules. Moreover, it can happen that the rule is working according to the specification, but it doesn't reflect the business expectation anymore due to the long elapsed time. So it is a big difference in quality if this cycle is radically decreased, and it can become independent from the completion of the caller programs. A precondition for this is that the rule description formalism is understandable without any special IT knowledge, using only a pure logical thinking. This leads to the fact that the business IT alignment, or as you formulated it, the communication between the two parties, can visibly improve, and really, the decisions can be refined until they are error-free by stakeholders and business analysts, and independently, but at the same time, the process that uses the rules can be built and completed by developers and testers.
I would like to tell a short anecdote about rule validation and the conflicts around the birth of the methodology. It turned out that the business side started to protest vehemently when they had to validate their own business rules. They said these were so-called IT deliverables. They totally declined to validate anything before the completion of the entire user system. Eventually, we agreed that they are willing to have a look at the descriptions in the rule templates. These descriptions document the rule in free text, but they are exhaustive and exact. They stipulated, however, that they are not interested at all in the formalized logical expressions. In practice, After 10 minutes into the meeting, they continuously pointed out things in the formal part, and not in the textual documentation of the rule. This is a logical language. It connects equal to, less than, greater than, and so on conditions through and or not operators. Usually, it's natural for everyone. And even if it requires certain mathematical affinity to write in such a logical language, understanding it is completely natural, especially because we typically have to work on rule validations together with people having excellent capabilities in their own specialty areas. I would like to talk about one more thing related to unit testing, and I'm interested in your opinion. The number of possible cases for business rules and generally for decisions is usually multiple tens of thousands or even more in case of medium complexity. So this is the so-called decision space, the number of possible combinations of input parameters, and this is the number of verifications to decide whether the output is okay. It's worth thinking it over when somebody thinks traditionally and wants to test using the delivered system, its user interface and the rules uploaded into it. In order to consider this tested through the user interface, we have to click through 10,000, 100,000 or more test cases using the interface. It's impossible. The user interface can be and should be used for testing whether the application operates according to the rule's decision. That is, when we expect a yes-no decision from the rule, does the system work accordingly or not? This means 2 test cases through the user interface. Besides, the rules have to be unit tested, broken down to units that are transparent and can be handled as a standalone entity from the business point of view. While the problem space can be of several billions with regards to the whole multiplication, the units tested separately can be really considered tested using a number of test cases with the order of magnitude 1000. On the opposite, running a test script having 1000 elements through the application maybe doesn't even scratch the actual test coverage of the rules. Let me put here once more a visualized representation of the declarative rules, that is, what we generally consider as properly implemented rules, and how they should work. It's an analogy to traffic signs. Let's imagine we approach this crossing from downwards. We need beforehand the information about the directions we can choose, otherwise we will have a frustrating experience if we try to turn right and we realize we shouldn't have done this. Another problematic case is when there is no actual prohibition, but the rules offering the possibilities in the system are not in sync with those performing the enforcement. For example, what currencies can be used for lending. So when we delete a prohibiting rule, we also have to modify the rule offering the possibilities, otherwise there will be unused cases. This is actually a waste, since there will be products that won't be sold through the system in practice, although the rules would allow that. The optimal case is that possibilities and prohibitions are exactly and continuously in sync. TCPS and the declarative approach guarantee that these move together in all cases, since it is one single implementation. I would like to reflect on one more thing. There was a question whether we automate the whole decision at once, or can we completely automate the decision at all. I think even if automated the decision, it is practical to leave the possibility for human intervention. This can be implemented the following way. The rule should definitely approve in well-defined cases. It should definitely decline in other well-defined and precisely regulated cases. And in all other cases, it should take into account the decision of a user having appropriate authorization. So there will be decisions where we know that it can be automatically approved or declined, and those will practically fall through the system automatically. Between the two, there is a gray zone where we say that this is the subset of decisions that cannot be automated properly. Still, we wouldn't like to automatically lose the business opportunities, so we attach it to competencies, personal decisions. Here we get back to the authorization rules. If the decision rule prescribes a certain special human decision, then it is possible to assign to this special human decision an authorization rule that regulates who is entitled to make this actual decision having the given information. This is all I wanted to say in relation to decision automation, and I commented a few things in the first presentation. I would be glad to respond to any questions you might have.
I'm a business user, and you on the supplier side are sensing very similar things, almost the same problems. This is a positive feedback for me, and I think, for you too. I'm happy that eventually we received an answer about possible solutions. Obviously, enforcing these is a difficult and tough task in certain cases. So, as you said, the business users must participate and must validate materials created by IT people. Automation means for them a limitation, and they are not necessarily happy about it. These conflicts have to be controlled and the good solutions have to be found as explained.
Thank you all for the participation, and thanks for the valuable presentations. Goodbye.